Hi Sergei, welcome to the 4th edition of Nordic Data Science and Machine Learning Summit here in Stockholm. So before we continue, can you tell us a bit more about yourself, your background?
Yeah, hi Ivana. So my name is Sergei. I'm coming from Germany, from Airbus. I studied physics and philosophy and then did a PhD in physics, theoretical physics, applying not machine learning, but statistical models to discover new physics at the Large Hadron Collider. Then I went on to work in the aerospace industry as a consultant in the field of space operations. And then I went back to machine learning and to AI research, which I found very interesting, and was working for a German retail company on fraud prevention. And then I combined the knowledge from the aerospace industry and also from machine learning, and now I'm working for Airbus.
Two passions together.
Two passions are coming together.
Yeah, right. So you today you presented on the topic time series anomaly detection with deep learning. Could you clarify for us what are the time series in aerospace engineering, and how deep learning is actually employed in anomaly detection?
Yeah, right. So time series are very valuable assets we have. So we can imagine that the airplane is equipped with 24,000 sensors and more, and each sensor produces some reading in time, describing the health of the aircraft. So it's comparable to the electrocardiogram you do at your doctor's, which describes the health of your heart.
Right.
And so we have like a health description of the aircraft. And also we have time series from manufacturing assets. And we are trying to use it in order to predict unhealthy behavior. And we use deep learning to create a model of what it means to be healthy, actually. So like a model describing the heartbeat of a person under nominal conditions, when it's running and when it's healthy, how it behaves when it runs and when you rest and so on. We create a model of an aircraft, or one subsystem, of course, because an aircraft is very big, so maybe 500 sensors. And this model learns what it means to behave nominally. So when the pilot gives a command, something changes. When we adjust something changes. So this is a deep learning model predicting nominal behavior. And we compare the predictions of this model with the actual measured behavior. And the deviations between them may indicate that something is not okay.
Well,
and these are the anomalies.
That's really interesting to hear described. So, despite all the hype and buzz around deep learning and AI, it's also true that the adoption of these technologies presents a big challenge. What are some challenges with adopting deep learning in the aerospace engineering industry?
Yeah, I think in general it's true for all engineering and heavy industries, is that first of all you have to gain trust of the practitioners. So you rely on the knowledge of engineers and you get some time from them to work together with you to create value. So you have, from the beginning, aim at creating products which are trustable and which are robust, so that the people actually use them in their everyday work. If you create a model which is like, you start with a model which is not very good and roll it out to people, and they start to look at it, and if it makes false alarms every day, they just stop after 2 or 3 days, and it will never improve. So somehow you have to involve them from the start on, and try to create in the beginning a model which already gives some insight and some value to them, so that they use it every day, and we can, from this usage, we learn continuously and improve it. And of course, the other big question in the industry is explainability of the models, how to understand why the model is predicting something. In our case, it's not so difficult because we aim at human level performance, so that if the model is predicting an anomaly, an engineer is looking there, we assume that the engineer will understand that the anomaly is there or not, so he can qualify the prediction. In other domains, it's not the case, and then you have really trust the model.
Right. So besides anomaly detection systems, what are some other deep learning applications in the aerospace industry? How does actually deep learning help advance it?
Well, we will see application of all the buzzwords which we have on the market: NLP, computer vision, advanced optimization, chatbots. These are actually an anomaly detection. These are actually the pillars, for example, as defined also by Airbus, knowledge extraction. So we will see across the airline industry better experience for customers through deep learning. We will optimize the processes at the airports, at the maintenance facilities, and in production. So this is what we see. Maybe the turnaround time will be really predictable for the airline, so you don't have to wait. The aircraft is landed and you wait a long time before you can enter. And I mean,
As it's
it
now.
can be really optimized. And also, another important aspect is by using advanced methods and optimizations, we can also optimize the burn of the fuel, which causes also the CO2. So we can make some kind of first small step to improving the footprint of the whole industry. So these are some big topics. And then and further on, of course, the automation becomes a big topic.
So, Sergey, let's now talk about AI and aviation. How AI is transforming air transportation today?
So as I said, the whole topic will be felt by everybody, by the passengers, but also by the companies working there. And it starts small. The AI is easily applied somewhere where we like at the end customer market, so we can see it in search and so on, what we know from the internet. And the industry will be maybe not felt directly, but it will be implemented in the, as I said, in the manufacturing processes and improving our experience as customers. Maybe we will get some kind of new apps also as an end customer for the airlines, where we can, we'll be steering through the airport, providing exactly what we need in each moment, entering the plane at the moment when it's actually ready, delivered for us. Have a better customer experience and also increase safety.
Overall. And just like AI, the cloud is another significant technology shift that is impacting how software is being built and how it performs. So how do you see these two technology trends influence one another?
I would say the cloud enables the AI applications for us because we have to pool the data together from different assets to enhance it, to combine it, and to understand its behavior. So the cloud is our enabler to be able to pull the data in one point, to access it from different points, and then to roll out our models. And also bring the computing power to the data and to be able to actually create this exciting deep learning models, which need a lot of power.
Enable it, right.
Yeah.
So, Sergey, we have one last question. Considering the deep learning state today, what can we expect in the next 1 to 2 years in the context of aerospace engineering and in general?
Difficult question. So in the field of aerospace engineering, I would say that in 1 to 3 years we will see the rollout of all the models we're speaking about right now, which are being created, which are being tested. So it will become an asset and another tool. Hopefully it will also become just another tool for the engineers to create better products. Now they're very used to using Excel, Microsoft Excel, or other tools, spreadsheets in general.
Yeah.
And AI will become another asset, another tool in their toolbox. And we will have a lot of people trained in AI, working closely with classical engineering, so that the whole industry will be in a different state. In general, I would say we have big advances in the fields where reinforcement learning, which is very interesting right now, and maybe we will see how this can be implemented in also industrial settings, in which cases it can be implemented. I'm really interested. What will happen?
We just wait and see, right?
Yeah.
So thank you, Sergey, for being part of Nordic Data Science and Machine Learning Summit today, and thank you for doing this interview with us.
Yeah, thank you very much for the invitation. I really enjoyed it.